Now that we've set up a place to store our video, it's time to start adding some cameras. If you're planning on adding older cameras that have been on the market for many years, the required camera driver may reside in our freely available Legacy Device Pack, which would need to be downloaded from our website and installed on the recording server. Support for newer cameras that have been developed after the release of the software you're installing can also be added by installing the latest device pack onto your recording server. You do not have to update the Milestone software release version, nor do you have to install the device packs on all of your recording servers. Officially tested cameras and the minimum device pack required to communicate with that camera can be found on our website. As of the making of this video, there are currently well over 7,000 tested and supported cameras and devices, with more being added with each device pack released every other month. Also, it's a good time to make sure you've assigned static IP addresses to your camera, updated its firmware to the latest supported version, and changed its default password to something more secure. Remember, recording servers in Milestone can be located in very different geographical locations, and each recording server is responsible for controlling and communicating with the specific cameras that have been added to it. As such, when you add new cameras to the system, you do so from the recording server you plan to add the cameras to. So we begin by clicking on the recording server node and right-clicking on the recording server receiving the new cameras, and then choose Add Hardware. You'll now have a choice of either scanning the network for available cameras, specifying a range of IPs you'd like to scan, or manually adding cameras by entering the IP addresses directly. In this case, we'll add a new access camera manually to demonstrate that function. First, enter the login and password of the camera you'll be adding. The checked passwords are tried in order until one works to allow access. Be careful, with some cameras, such as those made by Hikvision, they have a feature that will lock out an IP address that is trying too many incorrect passwords. So either disable that function in the camera, or make sure your login and password is accurate and in the first checked spot to avoid the camera blocking your recording server. Next, since we know this is an access camera, we'll click the Clear All button and only check the access box. This will save considerable time by not having the system scanning for camera drivers that we know we won't need. Next, we can enter the IP address of the device, and if you have more than one camera, you can add additional IPs here as well. It's generally best to leave the hardware model option set to auto-detect. This will ensure the system chooses the correct driver for your specific camera. Click Next, and the system will locate the camera and confirm communication is possible with one of the drivers. Click Next again, and the camera will actually be added to the recording server. Uncheck any features or unneeded video channels that might also come in with the camera. Some cameras will load with a single camera represented, while other manufacturers, such as Axis, will often load with additional virtual cameras that can offer alternative video streams and other features from the camera, depending on the camera model. The next screen is where you will specify what default group you want your camera to belong to. We'll cover groups in greater detail later. Next, let's examine the camera settings. You can do this from the recording server, expanding the hardware and clicking on the camera, or from the Cameras node and choosing your newly added camera. Now's a great time to rename the camera if you wish to. Different organizations choose different naming strategies, but something that indicates the facility where the camera is located and possibly the manufacturer or IP address are all common strategies. Cameras show up alphabetically in lists, so naming cameras with preceding numbers or characters is also a common strategy. Our corporate and expert versions allow you to position the camera on an internet-enabled smart map. When this is done, the GPS coordinates of the location the camera was placed will populate below. Conversely, if you enter valid GPS coordinates here, the camera will automatically be plotted on the smart map. Note that if you wish to delete a camera from a smart map, the only way to do so is by removing the coordinates from this location. Next, click on the Settings tab for your new camera. Here you see a list of supported settings for this particular camera model. The fields represented here will vary from camera to camera depending on the available options. By default, Milestone generally uses Stream 1 for live viewing and recording, so this is where you should focus most of your attention. Take a moment to note the frame rate, and most importantly the resolution. Set the frame rate to your desired FPS, industry average is 8 to 10 frames per second, and choose your desired resolution. Many cameras will automatically import at an undesirably low resolution, so it's important to check this and increase the resolution if needed. Another important setting to be aware of is the max frames between keyframes. This manually determines the rate that keyframes are sent from the camera. Industry average is 1 keyframe per second, so generally you'd enter the same number here that you used for your frame rate. For example, if your camera is running at 10 frames per second, entering a 10 here would produce 1 keyframe per second. Entering a 5 here would produce 2 keyframes per second, or 1 every 5 frames. If you do want to change the values here, be sure to also change the max frames between keyframes mode from default to custom. Otherwise, the camera will continue with the default keyframe setting established in its firmware. Note, however, that people will generally leave this to the default setting, allowing the camera to manage its own keyframes. If the camera's smart codec can be configured in Milestone, rather than only configuring it in the camera firmware, you may see those options here as well. In this case, we'll turn on Axis Zipstream. Note that on many cameras, if you turn on smart codecs, or with Axis cameras, if you turn on dynamic GOP, this allows the camera to automatically vary the rate the camera is sending keyframes, which will save considerable bandwidth and storage, but dynamically varying the keyframe rate usually requires changing a motion detection setting that we'll cover in a moment. If you intend to utilize multi-streaming, you can configure the parameters of the other streams below, and then choose which streams are used for live and recording on the next tab. However, most situations don't require the use of this feature. Next, let's skip over to the Record tab. Here we choose if we wish for this camera to save recordings, the duration that the video will record if you click the manual record button in the Smart Client, where the video pre-buffering footage is stored, and how many seconds of video are available for that pre-motion buffer. Memory means the system is using RAM to store video prior to motion being detected. This means that the hard drives are only being engaged when video actually needs to be stored. The numeric value is the amount of time available for the pre-motion buffering. The actual amount that is utilized, however, is specified in the rules engine, as is the number of post-motion detection recording seconds as well. We'll cover the rules engine in greater detail in the next video. Next, we see recording frame rate. This only applies if your camera is running in MJPEG mode, so most users will not need to change this. The Record Keyframes Only option results in the system only recording keyframes that are coming from the camera and ignoring the additional in-between frames. This would result in live video that appears smooth, but recordings averaging 1 frame per second, or whatever keyframe rate the camera is configured for. This is generally only used when people want to record all the time, and also have a rule set up to make the system record all frames on motion, thus making the video appear to speed up when motion is detected. The next section, Storage, is important if you have multiple storage containers set up with different archival or retention times. This is where you can specify what storage location your camera should record to. If you only have a single storage location, then that will be the default, and you won't need to make any changes here. Lastly, if you scroll down, Pro Plus and higher users will see an option to automatically retrieve remote recordings. Checking this box will have the system automatically download any available video footage from the camera's memory card should there be a network or computer outage. Next, we proceed to the Motion tab. Unless there are special considerations, most users will always leave motion detection checked. This, combined with the Generate Motion Data for Smart Search option, provides you with a very fast Smart Search feature that allows you to draw a box on screen and quickly determine the times motion occurred in that space. Hardware acceleration should generally be left to automatic. If your recording server is equipped with an Intel CPU with QuickSync video support, or is equipped with an NVIDIA graphics card, it will utilize that to reduce CPU usage for the motion detection functionality. Below we see a graph that will move in relation to the amount of motion on the camera. When the green passes the black line, it turns red, indicating there is sufficient motion to trigger the event. Adjusting the threshold slider will move where that line is, making the system more or less prone to triggering with motion detection. Generally, people will leave the manual sensitivity setting unchecked, allowing the system to dynamically adapt to different levels of small, consistent motion in a scene. Next, we have Keyframes Only. This by default is checked, meaning that Milestone is only detecting motion when the camera sends a keyframe, which will vary based on the camera settings, but is usually around 1 per second. This is the most CPU efficient setting for the recording server. However, there are times when you may wish to detect motion more frequently. These situations might be a narrow hallway where a target could potentially make it across a scene in the time between keyframes, or if you have a smart codec enabled that will vary the rate the keyframes come in from the camera. In these situations, it's important to uncheck this box and manually set the motion detection frequency. The green dots appearing on the screen indicate areas where motion has been detected, and the rate that the green dots are updating indicates when keyframes are coming in from the camera, allowing you to judge how frequently motion detection is occurring. Note that if you uncheck this box, the refresh rate of the green dots will then match the value defined in this menu. The more frequently Milestone checks for motion, the more CPU power is required of the recording server. But it's a rather small incremental amount, so don't be afraid to use this feature, but don't uncheck them all by default either, without closely monitoring your recording server CPU usage to ensure it's not being overloaded. Lastly, scrolling down on the Motion tab, we see Exclude Regions. This is very important for masking out areas of a scene that experience frequent nuisance motion, such as trees and roadways. Check this box and adjust the number of regions to match your masking needs. You can also change the size of the pin used to generate the masking. Left-clicking masks an area, meaning that the motion detection in that zone will be ignored. Right-clicking removes the masking. This combination allows you to easily exclude objects that you don't want to trigger motion detection. It's advisable to mask off areas to be ignored first, and then do a final, more sensitive adjustment to your motion thresholds. The last thing we'll cover is the concept of grouping cameras. Camera grouping is a critical time-saving feature where cameras can be placed into one or more groups. This is useful if you want to apply settings changes to multiple cameras at once, have specific rules applied to multiple cameras, or to make locating cameras easier for your users. Make a new camera group by clicking on the camera's node, and then right-clicking in the Devices area. We'll make a new group, name it, and click OK. Now we right-click on the new group and edit it by choosing Edit Device Group Members. Here we choose what cameras will reside in this grouping. Note that if users on your system have access to any of the cameras in the group, they'll see that group name in the Smart Client software, so take care in naming your groups as they are always visible to your users. Setting up multiple groups consisting of cameras on floors or locations, such as north side cameras or 10th floor cameras, will allow your system users to have an easier time locating cameras that they need to add to their view layouts. Often, I'll also make a grouping preceded by an X and name it Administrative Groups, and within there I'll set up camera groups that I'm using for administrative reasons, such as for changing camera settings, or for rules to apply to. These groupings aren't particularly useful for system users, so by preceding the name with an X, it will put that folder at the end of the alphabetical list so as not to clutter up the area with camera listings and confuse users. And that covers setting up cameras. Continuing in the video series, we'll be adding users, defining their privileges, learning about the rules engine, and covering a few other setup tips.